Hello everyone, my name is Tamrin. I'm majoring in mechanical engineering. Today I'm going to show you a little bit about computer modeling in predicting tropical storms or hurricanes. I thought it was interesting because it just happened to us like a few days ago. Let's get started. First off, I'm going to show you guys some basic information about storms and hurricanes through a video from the National Geographic website.
Driving rain, killer waves. These are the hallmarks of a hurricane. Also called cyclones or typhoons, hurricanes are giant storms prowling the world's tropical seas. An average hurricane releases as much energy in a day as the explosion of 500,000 small atomic bombs. Hurricanes form in the summer and fall when the sun heats vast stretches of tropical ocean to over 82 degrees. Warm, moist air rises over these hot spots, creating thunderstorms. Upper-level winds and surface winds then come together, forming a circular pattern of clouds known as a tropical depression.
As you can see there, wind is made of air, and air is a type of fluid. There are two types of fluid flows, turbulent flow and laminar flow. Laminar flow is easy to predict because it follows a pattern. In contrast, turbulent flow is a very chaotic flow. It is extremely hard to predict how is it gonna flow in the next minute or next hour. Turbulent flow is considered to be a chaotic dynamical system. A chaotic dynamical system is a difficult system to predict, and it is significantly depends on the initial conditions. What do I mean by that? For example, I want to compute two numbers through a chaotic dynamical system. The two numbers are 0.0010 and 0.0011. Notice that they are not significantly different, but when we compute it through a chaotic dynamical system, we could have a completely different result. One could give me 1, and the other one could give me 10,000, for example. So weather is considered to be a chaotic dynamical system. As you can see on the video, the flow you cannot predict it. Although it's hard to predict, but we really want to predict it as much accurate as we can. Therefore, scientists are trying to understand more about the chaotic dynamical system. Let's continue watching.
When the winds exceed 39 miles per hour, a tropical storm has developed. When the winds reach 74 miles per hour, a hurricane is officially born. Inside the storm, bands of rain up to 300 miles long meet in the eye wall, the most violent section. Here, winds of up to 200 miles per hour spiral upward. Within the center of the hurricane, downdrafts of dry air create a strangely calm area called the eye. Fully formed, a hurricane may stretch over 500 miles in diameter. That's a storm nearly the size of Texas and reach a height of 9 miles. Most of these storms spin out over the open sea, but in an average year, 2 or 3 will strike the mainland of North America. When they do, the damage can be catastrophic. Most dangerous is the storm surge, a wall of water that sweeps across the coastline where a hurricane makes landfall. About 45,000 people were killed by hurricanes in the 20th century, including some 15,000 in the United States. Hurricanes are also costly in dollars. 1992's Hurricane Andrew.
Okay, so as you can see, it is so important to predict hurricanes. Where is that gonna go, right? So meteorologists use the computer's model to predict the path of hurricane. We had one hurricane along the Mexico coast from June the 10th to June the 17th, 2015. So it was few days ago. What I did was I took screenshots of the result of the computer models at different times to see which model give the most accurate result compared to the other. The first picture was updated on June the 15th, 2015 at 4 p.m. The different color line right here are the result of different computer models. And the name of the hurricane is Hurricane Carlos. The blue line predicts that Carlos is going towards the coast, whereas the other one predict that it's gonna go towards the ocean. The computer models use almost exactly the same initial condition. They might be slightly different in rounding errors or measurement error, but you can see how diverged it is as time goes by. See, just start from the same result at the beginning is kinda similar, but as times go by, it's diverged, and it's one goes here and the other one goes here. See, it's completely different. The second picture was updated on June the 16th at 4 p.m. 4 a.m. As the blue line predicted, the hurricane came closer to the coast. You see it closer. You see the curve right here and the curve right here. They are the same, and you see the hurricane get closer. So the first picture of this line is exactly the same as the other one. Of the last picture of the previous line, I copy it here so it's easier to compare. So the third picture was updated on June the 16th at 10 a.m. In the previous picture, the blue line predicted that it's going to go away from the coast a little bit. See it go away from the coast. And you can see that the third picture, it actually went away from the coast. From the original position, maybe right here, and it went away a little bit. And it's predicting that it's going to go back to the coast again and go closer to the coast. So the next picture was updated on June the 16th at 10 p.m. And again, this one was exactly the same as the previous one right here. PM it shows that the hurricane went back to the coast of Mexico. The blue line is still predicting that the hurricane is going to go towards the coast. It didn't predict that it's going to actually happen on the coast though. It's close. The next picture was updated on June the 17th at 10 a.m. It shows that Carlos actually went on land, you see? Luckily, it wasn't a hurricane. It was a tropical storm because the wind went 40 miles per hour. The other computer models predicted that the hurricane was going towards the coast, but the position was still further away from the coast than the blue line. Right here. The red line predicts it's going to go back down, which is not true at all. The last picture was updated on June the 17th at 4 p.m. It was still on land, but now it is only a tropical depression. It's only 30 miles per hour. So as you can see, the blue line is the most accurate computer models compared to the other ones in predicting the path of Carlos. This is the overall path of Carlos, which is progressing from the tropical depression to tropical storm, then to the hurricane, and go back to the tropical storm and tropical depression. I only took picture when it started to become a hurricane right here. And you see, comparing to the very beginning picture, you can see that the blue line is the most accurate computer we have. So imagine the blue line were not there, meteorologists would think that it was going out to the ocean and not really affect the land. The people would not have been prepared. Once it came on the land, it could have been a catastrophic. In conclusion, understanding the chaotic dynamical system is extremely important, and creating an accurate model that represents it is also crucial as well. So that's my video. Thank you for watching.